So in this step, the extract consensus sequence, this to me is kind of the most important part. It's great to sequence SARS-CoV-2. It's fun to do the analysis, look at variants, but the real value in performing the sequencing from a public health perspective is to share the sequences so that they can be analyzed in the context of the entire pandemic. How are viral strains moving around? How are viral strains being introduced to different regions? So it's critically important to share it. And in order to share it, you will be sharing raw data to NCBI with the sequence read archive, but you'll also be sharing consensus sequences with hopefully both GISAID and GenBank. So right now I'm going to show you how to get the consensus sequence. So let's move this over a little bit, create a little room. We're going to add a new element, and creatively it's called extract consensus sequence. Let's see, extract consensus, there it is, extract consensus sequence. So we've added this, and what extract consensus sequence needs in order to as an input is your reach tracks, your local realignment, your sequence mapping from your local realignment. And we'll perform an output, and we'll save this into a new folder called consensus input and consensus sequence. Okay, let's see what parameters there are, if there's any. Low coverage definition would be 0. For this one, we're just going to keep annotations. We're going to keep everything in default. But once again, if you hit help, it will go in and talk about, actually, we can't set a low coverage definition here. Let's set this at 5. Okay, anything less than 5-fold coverage, we're going to call that low coverage. So let's finish, and let's save this as a new workflow. 11. Step 11 consensus sequence. Okay, and let's run this. So let's save, run. And you know the routine. Step 11. Okay, so this is running. So instead of pause, I'll pause in a second as this is running. But, this is really going to be important, especially when, from a public health perspective, many of us that are performing Arctic sequencing right now of SARS-CoV-2, we have runs of 48 specimens, sometimes more, and we're going to look at these in total and look at all the QC steps, and we'll be getting to these batch functions shortly. But this consensus sequence is a really important part. Every one of these is going to export out a consensus sequence, and we will be designing a separate workflow in order to rename these consensus sequences for submission to both GISAID and to GenBank. So there'll be more on that in other videos with a different workflow. So let me pause this while it finishes and be back in a few. So that's finished. Let's take a look at the output. So you can see the value now of having these different folders for sorting things, and this is going to be even more important when you have multiple specimens running at the same time. We have the track list, but we also have this consensus folder now, and if we open this up, we have our consensus sequence here. And there's going to be ways that we'll rename this and other workflows and look at pass-fail, but that's how simple it is to extract out a consensus sequence in this workflow. So I can close that and make sure that workflow is saved. So we have one more step to finish on the single specimen analysis, and that's the QC for read mapping. So be back in a few.